It is a commonly held belief that the transition away from venting pneumatic equipment, that's the equipment that runs on methane gas, that powers a lot of the oil and gas infrastructure around the world. That transition, it just requires a big amount of capital and provides essentially no financial return back to the operators. It is purely a, call it a administrative or a compliance exercise. So I'm here today to debunk that commonly held belief. I am Dean Pick, the president and founder of Kinitics Automation Limited. Our company produces industrial grade equipment, primarily for motion control and automation, using our platform technology, which is based around shape memory alloys. We have placed this technology and have customers in a variety of industries, including advanced manufacturing, aerospace, transportation, but here today to talk about our applications in the energy sector. So for those who are unfamiliar with venting pneumatics, we're talking about a widespread industry practice in oil and gas, which uses the gas in the pipe, methane, natural gas, it goes by a few names, as the driving gas to run pneumatic equipment, which opens and closes the valves that permits the flow of these gases, liquids, etc., through pretty much the entire value chain. Upstream production, separation, midstream compression, downstream pressure letdown stations. There are millions of these devices throughout industry. This was a practice started pretty much since the inception, and they continue to operate today, even in the face of mounting regulations. But again, there is a lot of hesitation to move away because of that sort of sunk cost mentality and no return on investment, hard to justify it. So operators are kind of very understandably delaying it as long as possible. So we worked for the last 5 years with the Canadian gas industry to bring to market a solution to this problem. What we really set out to do was develop the best valve controller we could. And what we did and came out with was a certified device for hazardous area locations that could mount on existing valves. We are not a valve manufacturer, but we've produced a product that sits on top of a valve and operates it. It doesn't matter whether it's inline existing brownfield equipment, we can mount in there in situ. Greenfield applications, we can pre-attach valves of any type to our product in your valve shops and fabrication shops deployed to sites. What we've done with this design, which I'll elaborate on in later slides, is come up with a design that provides high uptime, no maintenance costs, and ultimately through a combination of low capex as well as low ongoing costs, delivers the lowest total cost of ownership against the competition. And through this case study, which I am presenting today for the first time, we've unlocked a $100 million enterprise opportunity for medium to large operators. So how does this device work? Why is it different? What we have done is we have taken the pneumatic spring from those pneumatic actuators and built a different driver mechanism around it. Our proprietary technology is based on shape memory alloy, which we are basically using to replace the diaphragm actuator so that the spring does its job. It provides the thrust, which closes the valve and keeps the pressure behind. And this allows us to retain that essential fail-close feature. What we have done, though, is replaced a chronic source of maintenance and problems, which is the diaphragm actuator itself. This is a pneumatic system. And how we've done that is use the properties of SMA material to oppose the spring. So it is an electric actuator, and in its natural state, idle state, it is the spring that provides the closure thrust, just like a pneumatic actuator. However, when you want to open the valve, operate the valve, these wires are like conductors. We can connect to a variety of voltage or power sources So we have products for 24 volts DC for remote sites. We have devices for 120 volt AC. We pass that electricity through the wires, and they excite a material change which literally realigns the molecules to allow us to pick up the spring and open the valve. It is not open, close, or bang, bang. We can actually control the way that this power flows through the material to get extremely fine positioning control. And it's a technology we've proven out through millions of cycles, and the way that we've arranged it is in line with the valve stem. So there is no metal on metal contact, there are no lubrication points. We maintain a high quality wiper seal just to keep the environmental dust and debris out, but otherwise it is a floating actuator. And through this design, we're able to provide a very highly reliable system that can cycle millions of times, and in the event of any site disruption, power, signal, you name it, you can have the confidence of spring closure, which is essential for your facilities designs, your HAZOP studies. So the case study that I'm presenting today, and we're really excited to be doing this, is based on our first US field deployment on a midstream company. We were connected to the Rose Rock Bridge program through a cohort program running between 2025 and 2026, a fantastic program based out of Oklahoma. This allowed us to connect to midstream customers within and around the Oklahoma area. And we came to site here, which was a gas compression site with 3 engines running. And we were brought in on the first 2 problems here. They were struggling with these gas lines, wet gas, freezing up in the winter, causing their entire engines to drop out. Small valve controlling a big asset, single point failure. And of course, these were also venting pneumatics, which was this compliance problem, which also was releasing their own product to atmosphere. What we came to appreciate over time since deploying, though, was that these customers were also suffering from basically bad fuel mix, air fuel mix going to their engines, constantly running lean, constantly running rich, and disruptions that were happening when these engines were coming on and offline, which were tripping the entire site. Basically, one engine comes up, suddenly there's a disruption on the fuel line, all engines drop out, whole site goes down. Big problem that we became aware of after the installation. So let's talk about the installation. This is before. What they had was a fairly modern control system that was sending an analog control signal into this called I2P device. What does that really mean? A 4 to 20 command signal is being converted to a pneumatic controller, shown here, taking fuel gas, injecting it into this diaphragm actuator, and then also releasing that methane gas to atmosphere. If you see the after, we actually really simplified the process diagram. We eliminated this piece of equipment entirely, this controller, and because our product has the standard kind of industrial interfaces, we were able to take that analog signal, the command signal, straight into our device. Power at this site was 120 VAC. The installation took less than an hour per device. We had bracket kits so that we could land on existing valves, kept everything in process, very simple lockouts, very simple isolations, very simple and quick to bring online, which you can see here were all outdoor locations. This was a 2-stage letdown. So they took interstage gas, dropped it down through this device, and then again on the device shown here. So we came in on a value proposition and an ROI on direct savings. This would be the costs of not having to deal with the maintenance headaches of these pneumatic devices in the field. But what really was truly a discovery for us and our customer was the device was just better at doing its job, valve control. What does that really mean? That means that the pneumatics, the kind of electric to air conversion was introducing these small delays and latencies in their process control, and that was manifesting into swings on their fuel line. So, these types of equipment and even a lot of electric drives have something called deadband. So there's a hesitation and sometimes an engineered delay so that they're not constantly consuming gas or consuming electricity or inducing wear and tear. We don't suffer from any of these things. So what we have been able to do is provide them with excellent control. Tiny micro adjustments, very fluid in nature. If anything, it's almost like taking that 4-to-20 analog signal and actually delivering analog or fluid motion at the valve. And by making those small micro adjustments, we were able to provide them excellent position tracking, which would dampen out the on and off nature of the compressors naturally coming on and off. By doing so, we eliminated their engine trips, which otherwise would require an operator or a maintenance individual to jump in a truck, go deal with a site problem. Site is down. At the same time, they were monitoring their air-fuel ratios and telling us, hey, look, we're actually getting excellent fuel delivery of these engines. They are running happier, they are running better. We believe, through this extended use of your equipment that we can potentially extend the life of these high-value compressors and basically defer the major overhaul and maintenance cycles, which add up to significant dollars. So the indirect savings that our product was able to deliver added up to a number that far exceeded the direct savings of the direct maintenance that we were able to eliminate on the pneumatics. That particular customer has about 550 compressor stations online. So we take that total of direct and indirect savings, and on an enterprise scale rollout, we can deliver a medium to large size operator over $100 million return on investment. That is a 2,600% return on investment when you look at the cost of our actuator and the small infrastructure changes and requirements to hook this up into a midstream facility. This is a return on investment which would otherwise be considered totally just CapEx, for the sake of emissions reduction, which in itself, of course, is a good cause, but hard to justify for your accounting departments and your project approval departments. It's possible. This is not theoretical. We've demonstrated this, and we hope to develop other customer relationships to allow us to expand and deliver on this value. So, how do we compare to the market, to the competition? What we have done is taken the best of pneumatics, which is the fail-close mechanical return spring. We've also taken the best of an electric drive, which is the low infrastructure requirements. You don't need all the equipment that you would typically need to run an instrument air system at your remote sites. You don't want to have a man present or a woman present constantly maintaining this myriad equipment required to deliver air. In addition, we are able to provide that enhanced control that I was speaking to on the prior slide to provide better control of your control loops, better control of your equipment, in addition to the low maintenance touch of our devices. All this adds up to the next generation of process control equipment for your sites. We have sold and installed product into a variety of applications, all listed here. Gas separation, shown on the far left slide, installed at Tourmaline Oil Corp. That's Canada's largest natural gas producer. We've installed products into other applications, including recycle gas at midstream stations. We've sold product into pressure letdown stations for distribution and downstream customers. Truly consider this a general purpose actuator that you can place anywhere throughout your process. Notably, that customer that I was just highlighting on the case study, within a week of installing the first set of devices at that station that was pictured earlier, they went and took another device off the shelf and installed it at a site 1 week later on a single pressure letdown station, even enhancing that ROI further, not requiring two devices to deliver the same returns. They didn't even tell us they were going to do this. We had recommended, hey, we're here, we want to be on site, let us help you install it. They just called us afterwards. This was actually a picture snapped by one of the operators there and said, oh, hey, by the way, we've got another one in. No sooner had they done that they installed on another site, and we're going to get our 4th site up and running this month with them. So we're seeing an accelerating uptake. They're realizing the benefits, and this is a positive story that we would like to share and help other companies realize. So our company, Kinitics Automation, based in Vancouver, BC. We have a strong team of STEM employees that are allowing us to bring the next generation of products online. We have manufacturing in North America out of our Vancouver facility. It is a model certified shop, so we go through quality audits from our product certifier. We are backing it with sales support offices where we have people in Calgary, Alberta, as well as Tulsa, Oklahoma, able to come to you, come to your sites, find the right solutions, ultimately come up with a value prop that makes sense, and back it up with field engineers that can go install the product and deliver results. So we're happy to count many customers as our stakeholders and customers on our journey. We got our start in Canada through Emissions Reduction Alberta, CRIN, as well as NGIF. We're currently working within the Rose Rock cohort this year to basically deliver results both for the customers, but as well provide economic benefits to Tulsa, Oklahoma, and the surrounding region. One of our largest investors is the Natural Gas Innovation Fund. I'm joined today by our director, Akil, who is part of that organization, and we count quite a few of the LPs as our current customers. In Canada, we've set up our supply channel partners with a company called CVS Controls based out of Edmonton. I do have an ask for the crowd today. We are looking for supply channel partners in the USA. We are currently registered, incorporated in America, able to direct supply to you, but we are wanting to hear from the audience, who are your best preferred vendors? That includes distributors, valve shops. We would like to have conversations with them to figure out the best way to deliver these solutions to you and to your sites. So I'm here to say that for the past 5 years, we've been working hard, and we're now, as of 2 years ago, commercial with this product. Let us help you actually get an ROI and eliminate your methane venting while we go about that. Thank you very much.
Dean, thank you. Thank you for sharing with us your impressive technology. Is there any questions? Don't be shy.
So from like a user interface, are they still operated the same? So like in a operations room, it's still the same information that you would have on any other actuator, or is that a different kind of process?
Very good question. So we have built in your standard industrial interfaces at the device itself. How it would appear in your control room is no different than any other electric drive. Oh, they've taken my slide down. Anyways, that little icon with the electric valve. Let's go back a few. This is what they would see on their control boards. Your technicians in the field, they're going to see the kind of standard terminal strip where they can install the control and power wires. So what we've done is basically conformed. We're not asking anybody to change, industry standard practice when it comes to hookup, control. It is just meant to do a better job than the incumbent.
Any other question? Okay.
Great presentation, by the way. Thank you.
Let's
say the future is not that far away. You have 50,000 of these devices installed. How do you monitor the health of the installed base? And how would you know when things need repair and maintenance, etc.?
Yeah, great question. So thanks to a project we ran last year, we have started to build in continuous condition-based monitoring, basically algorithms that are constantly running to ascertain the health of the device, as well as ascertain the health of the connected device. So we're able to provide advanced notice in the event of any impending failures of the device. we're also able to alert the control rooms to any issues with the valve itself, be it a frozen valve or a object or debris that is pinning the valve open. In order to get those benefits at the kind of lowest level, we have a switch, like a, hey, there's a problem switch. We also have a light indicator on the side, shown there. Flashing blue to let you know everything is nice and healthy, goes orange if it detects a problem, goes red when something is quite severe. We also have a serial communication interface, Modbus. So for those that have and want to get more, juice from the lemon, all of this is standard equipment. Hook in Modbus, you'll get the benefits of that advanced diagnostics.
Is it only failed close, or are there other options?
So currently with the KVA 38 product that we're presenting today, it is available in failed close exclusively. We have heard that, about 5 to 10% of the applications require fail open. It is in our product pipeline to bring fail open equipment online, basically as part of an expanding product catalog. In fact, I'm happy to say we just secured some non-dilutive funding, allowing us to get this next generation of products onto the market. So we appreciate that there are these kind of niche applications that require fail open, and we look to address those in the future.
Even fail in place?
So great question. So fail in place, I think, would be a bit of a challenge for a spring-loaded actuator. In this case, we have no plans to bring fail last to market. But there's a few creative ways that I think we could still achieve the same results. It may require you to take one possible step back from facility design. But again, we're here to work with you to realize both a safe and a reliable facility design.
Any other questions? Dean, thank you so much. Congratulations. And with this, we conclude our session. Thank you.
Thank you.
Thank you.